All right, let's get straight into it. We're tackling one of the biggest, most important topics in higher tier algebra, solving equations and inequalities. This stuff is a huge part of your exam, so we're going to make sure you feel sharp, confident, and ready to bag every single mark. Look, I get it. Algebra can sometimes feel like you're trying to solve a tricky puzzle in the dark. But honestly, once you know the rules and the strategies, it all clicks into place. Think of this as a workout for your algebra muscles. We're going to get you totally exam fit. Let's do this. So, here's our roadmap, covering all the key bits from the syllabus, A17 right through to A22. We'll kick things off with linear equations, then level up to quadratics, solve some simultaneous equations, get our heads around iteration, and finish strong with inequalities. By the end, you'll have a full toolkit ready to go. First things first, we have to start with the absolute bedrock of all of this stuff, linear equations. If you can nail this, trust me, everything else we're going to cover today becomes so much easier. This is the foundation we build everything else on. So what do the examiners actually want to see? Well, they want to know you can take a linear equation with one unknown, usually an x, and solve it using your algebra skills. The real test, especially for higher tier, is knowing what to do when that unknown x pops up on both sides of the equal sign. Let's break one down. The main goal here is to get all the x terms together on one side and all the plain numbers on the other. So, first move, as you see in step 1, we get rid of the smaller x term by subtracting 3x from both sides. That leaves us with 2x minus 6 equals 2. Simple. Next, we want to isolate that 2x, so we do the opposite of minus 6, which is adding 6 to both sides. Boom, we get 2x equals 8. And for the final step, just divide by 2, and there it is, our answer. X equals 4. Okay, awesome. Let's take that skill and move up to the next level, quadratic equations. These are your classic high-mark exam questions, so having a solid set of tools to solve them is an absolute must. And the syllabus is super specific here. It's not enough to just solve them, you need to know 3 different methods. So let's look at what they are, and more importantly, when to use each one. Right, here's your toolkit. Think of factorizing as your first port of call. It's lightning fast, if it works. Completing the square is a really powerful method, and it's also essential for other things like finding the turning point of a graph. And then you've got the big one, the quadratic formula. It might look a bit scary, but it's your ultimate safety net. It will solve any quadratic you throw at it. Guaranteed. Let's give factorizing a go. For x squared plus 2x minus 15 equals 0, we're on the hunt for 2 numbers. They need to multiply to make the end number, negative 15, and add to make the middle number, plus 2. After a bit of thought, you'll find the numbers are plus 5 and minus 3. So we can rewrite our equation into 2 brackets, x plus 5 and x minus 3. Now, think about it. For 2 things to multiply together to make 0, one of them has to be 0, right? So either x plus 5 equals 0, which means x is negative 5, or x minus 3 equals 0, which means x is 3. 2 solutions, job done. Okay, next up is completing the square. Now the trick is to look at the number with the x, which is plus 6 here. You have it. That gives us plus 3. We write that inside a squared bracket. So we have x plus 3 squared. But wait, if you multiply out that bracket, you get an extra plus 9 that wasn't in our original equation. We can't just add numbers in. So to keep everything balanced, we have to immediately subtract that 9. Then we just bring down the original minus 5. Tidy that up, and you get x plus 3 squared minus 14 equals 0. From there, it's just rearranging to get x on its own. And here it is, the one that never lets you down, the formula. Now, the first step is absolutely crucial. Correctly identify your A, B, and C. A really common mistake is messing up the signs, so be careful. Here, A is 2, B is negative 5, and C is negative 4. Once you have those, you just have to carefully plug them into the formula and work through the calculation to get your 2 answers, one for the plus and one for the minus. Great stuff. We're making real progress. Now we're going to look at solving 2 equations at the same time. You know, when you're given 2 equations, you're basically looking for the one specific set of x and y values that make both statements true. If you think about it graphically, it's just the point where the 2 lines intersect. So the syllabus says you need to be able to handle 2 linear equations together, but the real step up for higher tier is solving a pair where one is linear and one is quadratic, and this almost always uses a method called substitution. Let's walk this one through. The first equation tells us that y is exactly the same thing as x plus 1. So we can just swap out the y in the second equation for x plus 1. This is the magic step because it leaves us with just one big equation with only one letter in it, x. It turns out to be a quadratic, which you know how to solve. But, and please listen to this, do not stop after you find x. That is a classic exam mistake. You have to take your x values and plug them back into the easy linear equation to find the y values that go with them. All right, time for something a little different. Iteration. This is a super powerful process you use when you can't find a perfect, exact answer. Instead, we use a special formula to create a chain of answers that get closer and closer and closer to the real solution. So yeah, this is all about approximation. The examiner will always give you the formula and a starting value. Your job is just to follow the repetitive steps to zero in on the solution. It's more a test of being careful with your calculator than anything else. So how does it work? Well, we start with our given value, x naught equals 1. To find our next value, x1, we just plug that 1 into the formula. Then, to get x2, we take our new answer for x1 and plug that back into the formula. You see, you're creating a little feedback loop where the output of one step becomes the input for the next. Keep doing that a few times, and you'll see your answers start to settle down and converge on the final solution. We're on the home stretch now. Let's talk about inequalities. With these, we're not just looking for a single answer, like x equals 4. We're actually trying to find a whole range of values that work. We're thinking less than or greater than, not just equals. The syllabus asks for two key skills here. First, you've got to solve the inequality itself. And second, you have to be able to show your answer properly on a number line. Now, for quadratic inequalities, there's a really important step that a lot of people miss out. To solve a quadratic inequality like this, your first move is to just pretend it's a normal equation. Solve x squared minus x minus 6 equals 0. This gives you what we call the critical values. They're the points where the graph crosses the x-axis. Here, that's at 3 and negative 2. Now for the vital part. You absolutely must sketch the graph. It's a positive x squared, so it's a U-shape that crosses the axes at negative 2 and 3. The question asks where the graph is greater than 0. What does that mean? It just means where is the curve physically above the x-axis? And from our sketch, we can clearly see that happens in two places. Way over to the right, where x is bigger than 3, and way over to the left, where x is less than negative 2. Okay, let's do a lightning-fast recap. Linear equations, isolate the variable. Quadratics, use your toolkit. Simultaneous equations, substitute. Iteration, it's that feedback loop. And for quadratic inequalities, find those critical values and then always sketch the graph. Wow, we have covered a serious amount of ground. But watching this is only half the battle. The key now is to actually do it. So have a think back. Which one of those topics fell a bit shaky? Was it completing the square? Or maybe sorting out those inequality regions? Pick one, find some practice questions, and try them right now while it's all fresh in your head. You got this.